Besties, and welcome to my YouTube channel. In today's episode, we'll be talking about projectile motion. In physics, projectile motion is a fundamental concept that unveils the captivating nature of objects propelled into the air, guided solely by the force of gravity. Now, what is projectile? A projectile is an object thrown into space upon which the only acting force is gravity. The primary force acting on a projectile is gravity. This does not necessarily mean that other factors do not act on it, just that their effect is minimum compared to the gravity. The path followed by a projectile is known as a trajectory. A baseball batted or thrown is an example of a projectile, a typical one at that. So now, what is projectile motion? When a particle is thrown obliquely near the Earth's surface, it moves along a curved path under constant acceleration directed towards the center of the Earth. That is, we assume that the particle remains close to the Earth's surface. The path of which a particle is called a projectile and the motion is called a projectile motion. In a projectile motion, there are two simultaneously independent rectilinear motion. One, along the x-axis, that is the uniform velocity, responsible for the horizontal, the forward motion of the particles. Two, along the y-axis, uniform acceleration, responsible for the vertical, downwards motion of the particle. Now, we have a diagram showing projectile, parabolic motion of projectiles. Let us consider a ball projected at an angle theta with respect to the horizontal x-axis with the initial velocity u as shown below. As you can see, the diagram is there showing you how a projectile moves. Now, the point O is called the point of projection. Theta is the angle of projection and OB equals to is the horizontal range or simply range. You can also call it range. The total time taken by the particle from reaching 0 to B is called the time of flight. For finding different parameters related to projectile motion, we can make use of differential equation of motion. We have the V equals to U minus gt, S equals to ut minus half gt square, V equals to U square minus 2g square, where our u is our initial velocity, g acceleration due to gravity, and T time taking, x displacement, v our final velocity in a direction, making an angle of 50-degree upward with the horizontal. Question 1. What is the maximum height reached by the object? 2. What is the object total flight take time between launch and touching the ground? C. What is the object horizontal range? So now, maximum x above ground. Solution, we can see, just jotting down the parameters and my formula. So yeah, that is it. U square sine 2 theta over g, that's the formula for horizontal range. For maximum height, v square sine square theta over g. Then for your equation of trajectory, that's x tan theta minus gx square 2u square cos 2 cos square theta. Okay, so now in the given problem, now, I just represent v, yes, v theta as my initial velocity, which is 40 meter per second, my angle, which is 50 degree, and g, that's my acceleration due to gravity, is 9.8 meter per second. It is constant. Now the component y gives the height of the projectile and it reaches its maximum value when the component vy is equals to 0. That is when the projectile changes from moving upward to moving downward. Substitute and solve for t. Now put in your equation, substitute, and you get that's okay, yeah, that's 3.12 seconds. To find the maximum height, substitute t in the equation y and we get, you can see the formula, the equation, the solving. So at the end we got 47.6 meter. The maximum height reached by the object is 47.6 meter. You can see for the time taken, which is 2u sine theta over g, we solved it. Horizontal range is the horizontal distance given by x at t equals to t square. We have our range there, x equals to tu